And I'm going to tell you up front that this one is a combined gas law problem because a change occurs. We start off with a helium balloon that occupies 4,500 centimeters cubed. And this measurement was made at 748 torr. Then the balloon is released and it rises in the atmosphere until the pressure drops to 557 torr from 748. So this is sort of P1 and this is sort of P2. And this is V1, and the question says, what's the new volume? So we're going to solve for V2 here. What's constant? Well, it's assuming that the temperature is constant. Isn't likely to be actually true, but for purposes of making this simple, we can assume it. So the temperature is constant, T1 equals T2, and we can cancel them out. Also, we're going to assume that helium doesn't leak out of the balloon. If it doesn't, then N doesn't change either. So the variable values are here. P1 is 748 torr. V1 is 4,500 centimeters cubed. We're going at some point to have to convert that to liters in order to get our answer in liters. There's more than one way to do it. All of them are workable, and I will show you one. P2, as the question says, is 557 torr, and we got to solve for V2, and we are assuming that T and N are constant. So if we take the combined gas law in its full glory here, we're going to cancel out N1 and N2 because they're the same. We don't have to worry about that. And we're also going to cancel out T1 and T2 because we're assuming the temperature is constant. So this particular gas law problem boils down to whose law? Boyle's law. And that's what caused me to say Boyle's law before, erroneously. So P1 V1 equals P2 V2. And we have to solve for V2. So V2 will be V1 times P1 over P2. Just a slight aside, many times, I would guess at least a quarter of all the gas law problems that students bring me are due to the fact that when they solve for V2, they get it wrong. They just sort of look at it and say, V2 is this. If that happens to you, I think you really need to sort of back up and say, okay, I'm going to do this step by step for a few times until I really can do it by inspection. All right? So V2 equals V1 times P1 over P2. Seems simple, but many, many gas law problems are missed because of it. So we've got V1. Let's go ahead and convert it to liters, and then we can multiply it by the ratio of P1 and P2, which are both in torr. If one of them were in atmosphere and one were torr, we'd have to change them so they're both in the same unit. Does it matter what unit? No, because the units are going to cancel out. But they have to be in the same unit. Okay. So V2 equals V1 times P1 over P2. Here are the values. We're going to convert V1 from centimeters cubed to liters. 1 milliliter is equal to 1 centimeter cubed. So we can go from centimeters cubed to milliliters, from milliliters to liters, and that's 4.5 liters. Okay. So now we're going to solve for V2. V2 will be equal to V1 in liters, 4.500 liters, times P1, 748 torr, divided by P2, which is 557 torr. And as we look at this, this fraction here is going to be larger than 1, which means that V2 is going to be greater than V1. makes sense. If you decrease the volume, you decrease the pressure, volume's going to go up. Okay? And when I did the arithmetic, I got 6.04 liters. A comment here. The questions that I have chosen to show you, some of them come out of your textbook, some of them don't. I try to make a mixture of them so that you will see different approaches. And I try to leave a few in the book for you to go back to if you want some extra